Alright, young people, today we're going to work on solving systems of equations using 3 equations and 3 variables. You might want to pause this so you can have enough time to write it down. You might want to pause maybe the last example before you watch me work it out and do it yourself. But I want to jump straight into the examples. Lost my train of thought. By the way, the Falcons beat the Cowboys, and I just thought you should know that. Alrighty, so I'm going to go ahead and go to my examples again. You might want to pause this and go back to those. But in those notes, it tells you that the idea is for you, the person working the problem, is to create 2 equations that have just 2 variables. And so what you need to do in order to do that is you need to eliminate a variable in each one of these equations here. And I'll show you what I mean by that. I'm going to choose to eliminate my y's, and I'm going to do that with these 2 equations, and then I want to turn around and do it with these 2 equations here. So if I'm going to eliminate my y's, I'm going to rewrite this first equation as negative x minus and I am going to multiply this equation here by negative 1. Okay? So I'm going to multiply this equation by negative 1. I changed colors so that we won't get it confused with the original. So if I multiply this equation by negative 1, I get negative 4x plus 5y minus 4z equals negative 19. Okay? Now I go ahead and add the 2 equations together, and notice what happens. I get negative 5x. My y's cancel out just like I like, and you get negative 9z equals negative 17. I almost messed up. Negative 17. So that's one equation I'm kind of going to put in storage. Just hold on to that. Now I'm going to go back to my equation up here, my original 3 equations, and so that means I don't need that anymore. And now I'm going to use the next 2. Yes, I reuse one of my equations. I'm going to use these 2 here to eliminate my y's. Now, make sure you use different equations. Don't use the same 2 equations. So if I were to eliminate my y's here, notice that I don't have to do anything to these 2 equations. The y's are already ready. So I combine each equation. I get 5x. Those go away to 0, and I have plus 3z equals negative 1. Okay. Now, alright, so I have 2 equations here. You don't have to box this. I'm just showing you what 2 equations I'm about to use. I'm going to take both of those 2 equations here, and I am going to line them up on top of each other. Negative 5x minus 9z equals negative 17, and 5x plus 3z equals negative 1. Now I'm going to combine these 2 equations. All this is spelled out in those steps I just showed you. Now I have 2 equations with 2 variables, and so what I'm going to do now is take those 2 equations and do elimination again. So this is the 3rd elimination. So once I combine these 2, my x's are gone. They subtract out to 0. Negative 9z, 3z make negative 6z equals negative 18. And so I solve for z, and the z coordinate is 3. So that means out of my 3-part answer, the last coordinate is 3. Now, according to the notes, you take your solution here and you substitute it back into either one of these 2 equations, and it does not matter which one you use. Say I use this one. Now you want to substitute it back into one of these 2 that's in the box. Not one that has 3 variables, not any of those. It has to be one with the 2 variables. And when I do so, I'll substitute it in here. 5x plus 3 times 3 equals negative 1. That's substituting 3 in for z. 5x plus 9 equals negative 1. Subtract, you get negative 10. Divide by 5, x equals negative 2. So now we have the x part of our answer, which is negative 2. Remember, according to the notes, it's going to be x, y, z. Or, what I didn't put on there is, it should always be alphabetical order. Okay? Make sure whatever you're doing is in alphabetical order. So x, y, z, or a, b, c, or something like that. Now, in order for me to find my third coordinate, I'm going to take what x equals, and I'm going to take what z equals and substitute them back into either one of the original equations that has 3 variables in it. Let's stick with this bottom one here. If I do negative 2 plus 5y minus 3 equals negative 20, all I did was substituted z and x into this equation here for each variable. You get 5y minus 5 equals negative 20. Add 5 to both sides. You get 5y equals negative 15, and y equals negative 3. So your answer should be negative 2, negative 3, and 3. Alright? If you think you got it, you should pause and try the second problem out and see how well you do on the second problem. But I'm going to go ahead and work the second problem now. Okay, on this problem here, again, you want to look to eliminate your variable, one variable, so we can have 2 equations that has the same 2 variables. And so I'm going to choose to eliminate my x's here. And so if I eliminate my x, I'm going to rewrite this equation here, x minus 6y plus 4z equals negative 12. And then I am going to multiply this equation by negative 1. Alright? Multiplying that equation by negative 1 gives me negative x minus y plus 4z equals negative 12. Alright, when you put them together, notice I have opposites here, so that's going to work. I have negative 7y plus 8z equals negative 24. And so that is my first equation that I'm going to use as I'm looking for 2 equations that look like that, so I can do an elimination method. Okay, now I'm going to go to the next 2, the middle one and the third equation. And I am going to eliminate my x's. In order to do that, I need to multiply this equation by negative, 2. So I scratched that out. I hope it's not confusing, but I don't need that original number for this equation. Now I'm restarting. And so I'm going to multiply this equation by negative 2. So I'm going to have negative 2x minus 2y plus 8z equals negative 12. Down here, nothing changes. I don't have to multiply. Plus 5z equals negative 15. I go ahead and put these 2 together. And notice what happens to my x's and my y's. They both cancel out, which makes my problem a lot easier. This won't happen every time. I think I made a mistake. I did make a mistake. This should be negative 24. I did not carry my multiplication of 2 all the way through. I stopped here somewhere, and there should have been a negative 24, which means that this will be negative 39. Divide both sides by 13, and you get z equals negative 3. So part of my solution, which I am lucky to get it now, is negative 3. Notice I didn't have to get 2 equations that look like this because 2 of my variables subtracted out here. So I'll go back and substitute that into my only other equation that has 2 variables, times negative 3 equals negative 24. That's negative 7y plus a negative 24 equals negative 24. So I'm going to add 24 to both sides. And that is negative 7y equals 0. Divide by negative 7 and y equals 0. So we know the y part. Now I take the y and the z and I substitute them back into either one of these. And it doesn't really matter which one I use. Let's just maybe stick with the middle one. I don't know. X plus 0 minus 4 times negative 3 equals 12. Which is really just x minus 12 equals 12. If I can multiply x plus 12, subtract 12 from both sides, x equals 0. Alright. Did you get that answer if you worked ahead? Alright. Hopefully we'll have time for this one more. I'm looking at my time and maybe we won't, but let me run through it as quickly as I possibly can. I'm going to choose to eliminate, let's go ahead and eliminate A. And if I eliminate A in these first two, what I'm going to have to do is multiply this top equation by negative 4 and this bottom equation by 5. Alright? So that's going to be negative 20a minus 20b minus 20c equals 80, positive 80. Here we're going to get 20a plus 15b plus 15c equals negative 30. And so those cancel out and I'm going to get negative 5b minus 5c equals 50. So that turns out to be my first equation. Now I'm going to eliminate these two equations, the a and these two. And doing so, I don't have to consider the stuff in the red. They're not really there. I can just go ahead and add these two together. And I have 6b plus 6c equals 3. So I have two equations, b and c. So I'm going to put them together. Negative 5b minus 5c equals 50. 6b plus 6c equals 3. And let's say I choose now to eliminate my my b's. I multiply this by 6 and this by 5, and I will get negative 30. And I'll get notice what happens here. All my variables subtract out, and I'm left with 0 equals 315. Now, is that a true statement? No. Same thing applies. We have no solution. Alright guys, ask me questions. Good luck.